welcome to lesson 48 Math Marvels. In this lesson, we're going to learn how to evaluate exponents. This means you're going to be able to see me do two things: express exponents in expanded form, and you're going to do the same thing, and then evaluate and solve the expression with exponents accurately. So we're going to figure out what is the value of that number as an exponent as one whole number. Okay, let's jump into the beginning of this lesson. Math Marvels, as we get ready to talk about exponents, which will be really big in middle school and in high school math, let's try and figure out what these numbers are and why they grow so rapidly. So here's the situation. Which would you rather do? Would you rather get $2 a day every single day for an entire month? And I'll even say it's a 31-day month. It's the longest month of the year. Or would you rather have $2 a day, double each day, for 1 week? So for 7 days, would you rather have, starting from $2, this doubles, or would you rather have $2 a day? Think about it. Think about which one you'd want. And let's try and represent what this can look like. Let's start with the $2 a day. So on the first day you get $2, the second day you get $2, and the third day you get $2. And each day, no matter what, is the same amount, on and on and on and on and on, every single day. It's for our 31 days. So in all, I'm going to represent it using multiplication, because I don't want to add 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 again and again and again and again. It's going to get long. So let's say we add it all up, and you're going to get altogether $62. But each day is just $2. Even if I did this on, if I wanted to know the 10th day, it would still be $2. If I wanted the 14th day, you'd just add another $2. But in our second situation, it doubles. So on the first day, you get $2. On the second day, you get $2 times $2, or $4. On the third day, you're going to have $2 times $2 times $2 again, or $8. Haha, you may have thought 6 because you saw 3 sets of 2's, but it's actually 2 times 2 times 2. And on the next day, oh my God, 2 times 2 times 2 times 2. So that would be the same as 4 times 2 is 8, times 2 again is 16. So each day it is doubling. And the next day you get 32, and then 64, 2, 3, 4, 5, 6. And the next day, $128. But look at this, Math Marvels. Look at how many times I'm multiplying by 2, 2, 2, 2, 2. It's getting very complicated. And we have a way of talking about repeated multiplication, and we use exponents for that. So exponents are a way of representing repeated multiplication. And this is important because multiplication is the same thing as repeated addition. Exponents are repeated multiplication. So it's the same number being multiplied again and again and again. So for example, for 32, I had 2 times 2 made 4, times 2 made 8, times 2 made 16, times 2 made 32. Now I can write all that, but there's a very simple way of writing that. And what you do is you're taking that number that's being repeatedly multiplied. That's my 2. That's our base. And how many times did I have 2 times 2 times 2? How many times did I multiply it? 1, 2, 3, 4, 5. So that 5 is the exponent. Okay, so that is the same as writing 2 times 2 times 2 times 2 times 2. All right, so we express it as 2 to the 5th. That's how I would say it, 2 to the 5th, or 2 to the 5th power. And that's what we're going to work on today. We're going to talk about how to represent repeated multiplication using exponents. So hit pause so you can jot this down into your notes, and we'll get into our first teacher example. Let's try this in a real example. An athletic shop orders a box of ping pong balls. The dimensions of the box are 6 inches by 6 inches by 6 inches. So that's the length, the width, and the height. Inside the box, there are 6 layers of ping pong balls. Each layer has 6 rows and 6 columns of ping pong balls. How many ping pong balls are in the box? So again, a little bit complicated. So let's start off. We just want to know how many ping pong balls are in the box. At first, it sounded like a volume problem, but it's not. We just want to know how many ping pong balls are in there. And we know that the box has 6 layers of ping pong balls, and each layer has 6 rows of 6. So I know there are a lot of 6s in this problem. That's okay. Here's our plan. We're going to create a visual for this problem. We're going to try and see what's happening with each layer and chunk this down. Then we're going to translate the visual into a number sentence with exponents to show the repeated multiplication. We're going to expand this out to find the standard form number. And then we're going to check that we don't multiply the base times the exponent. In other words, we don't want to make that really silly mistake of 2 to the third power is 6. We know that it's not 2 times 3 when we see an exponent. We know that it means the base 2 3 times. So we're going to triple check that we don't make that simple mistake. Let's hit pause and jot this down into your notes. Okay, we're going to look at a visual for this. Again, please don't get emotional about the number part. I know for some kids, they see all the 6s and it can be very triggering. This is just an example part. And just try and work on the visualization of the problem. And we have a box. I'm going to try and draw a box. And that's what our box looks like. And our box has 6 layers to it. Six. All right, so there's 6 layers. Kind of like a cake stacked. So 6 stacks, 6 layers. And we know that in each layer, so I'm going to draw one layer. This is part of our visualization plan. One layer has 6 rows with 6 of these. Now just drawing this out is taking a lot of time. But I know it's helpful for some of us, so I'm going to take the time to do it. Okay, so in this layer, if I wanted to quickly count how many, I could, but I'm going to represent this instead. Instead of counting this out, I have 6 times 6. It's a nice array model, which I know would give us our 36. Now, so this is one row, but I actually have 6 of these rows. So not only do I have 6 by 6 ping pong balls, but I have this happening 6 times. So each one of these rows has a 6 by 6 ping pong balls. Okay, so instead of doing this in pieces, I'm going to represent this because I know I have 6 rows. 6 times 6 times 6. So I have 6 layers of 6 rows with 6 ping pong balls. And I could represent this as 6 to the third power. So that's how I would do it if I was just doing it as an exponent. Now, we want to know, so how many ping pong balls are there all together? How do I figure that part out? Okay, so I'm going to multiply 6 times 6 times 6. We're going to do this from left to right and do these first 2 numbers. 6 times 6 is 36. That's the first part I did. I'm even going to highlight it so we know this is what we did. 6 times 6. And that gave us 36. And now we just have to do 36 times 6. For time's sake, I'm just going to do this with my calculator. And I'm going to get 216. Okay, so that is how many ping pong balls are in here. 6 to the third power is the same as 216. There are 6 to the third power, or 216 ping pong balls. I'm going to just write that in there. And just naming, we have this written in expanded form. We've expanded it out. We have it written in exponential form. And then we did all the math to have it in a standard form. We're going to use those terms more and more in this lesson. Okay, standard form, exponential form, expanded form. But for now, hit pause so you can jot this down into your notes. We're going to use those three terms again that we just spoke about in the teacher model. Exponential form, expanded form, and standard form to represent our repeated multiplication. We're going to start with 8 to the first power. Our 8 is our base, so that is the number that's being repeatedly multiplied. And how many times is just one time, so it just stays there as 8. Okay, so it's just 1 8. And that's the same as standard form, nothing to simplify. Let's look at the second example, and here I have 12 times 12 times 12 times 12. So my repeated number is a 12, so that is my base. How many times do I have 12 being multiplied by itself? I have it 4 times. 1, 2, 3, 4. So to the 4th power, right? So 12 is my base, times itself 4 times. So let's figure this out in standard form. What would that be? Well, I know that 12 times 12, actually I'm going to write it all out. That's how I figure out standard form. And we're going to do it piece by piece. 12 times 12 is 144. Times 12, I'm going to have to do it a second time. Times 12 gives us 1,728. And now we're going to multiply this times 12. And that gives us 20,736. So exponents can get large very quickly because we're repeatedly multiplying. But notice how my expanded form helps me to organize my numbers piece by piece. This is a place where it's very easy to make mistakes. So rather than rush, I take my time. The most simple mistake I see kids make is they're looking at this and they see 4 sets of 12. And so a lot of kids just do 12 times 4 in their mind by accident. It's not that it's intentional, it's that our brains move so fast, they just see 4 12s. And we've done so much multiplication work that we go 4 12s is 48. This is what our brains sometimes do, so we have to slow down our thinking, and expanded form will help us to do that. Let's do the last one, 1 5/10 to the 3rd power. So that means our base is 1 5/10, and my 3 tells me to write this 3 times. And now let's figure this out in standard form. So we're going to do 1 5/10. We're going to do the first 2 numbers first. 1 5/10 times 1 5/10, which is 2 and 25/100. I'll show you how to do that in another video. Times 1 5/10. And that gives us 3 and 375. That is our standard form. So when you think standard, we want that one simplified number, that total number. And I just use expanded to help figure out how to slow down my thinking to get that number. Now, sometimes we will be using calculators, so please make sure that you are still keeping your work visible, even if you're using a tool like a calculator. I'm capturing everything in our notes. So hit pause for now, jot this down into your notes, and you're going to have a ton more practice with exponential form and how to expand it and put it into a standard form.